OK，我们等买家具进来就开始。有问题吗 ？Ariel 上次的练习有哪一题 specific 要讲解的吗？没有啊。你们是不是可以？是不是不用回学校啊？还是你们要回啊 ？SPM 学生好像是要回是 MCO，就算是 MCO。Okay, I think there's one more minute. He's coming. He's almost here. Okay, we will carry on the lesson because Jiajun said he house no electricity. OK， 没有吗 ？OK， 我们今天也是会照常也是会继续啊。So it's more like a one-to-one. OK。OK， 来，so 今天我会教 也是还在 equilibrium of forces 啊。那 before 我讲到新的，我先 recap 一下我们上次讲什么，so that when I teach it's very easy to absorb later. Now 一个 force 可以 divide 去两个 component。Okay? 不管它是 pointing in any directions， 我们都可以把它分成两个 component。Okay? X component 还有 Y component。Given the angle here， 我们可以 resolve 它。Okay? If the force is 100, then we can resolve this one is 100 cos 30 and this one is 100 sin 30。这个 arrow 这个 vertical component 我可以把它写去对面，我擦掉这个，我把它写去画去对面这边。所以这个 vertical 我们通常是写成 Fy， 然后 Fx。And this one is the resultant Fr. Now, any force can be resolved into Y component, X component. Okay, and then also any force can be added to get the resultant force. If you add this one and this one, you will get resultant force, and the resolution of forces is the reverse process. So this one is what we talked about in the last lesson. Now today we are going to apply this one in real life situations. So in a system of bodies. So what is system of bodies? 就是一个 system 里面有 more than one bodies in it. Okay, so understand the word system. System, let's say if I say the Earth system. The Earth system has the particles, the air particles, the object that you see around you, or the atmosphere, anything, okay, in the Earth. That makes up a system. That is the Earth system. On the other planet, Mars, we have Mars system, right? Okay, that is system. A system can have many bodies, okay, more than one members. Now, equilibrium of forces. Since you already know how to resolve forces and how to add forces, we are going to look at equilibrium system. Okay. Now this one I actually talked about this last year, but this one I will talk into more detail, the equilibrium of forces, because in the first chapter of your Form 5, you are going to learn the equilibrium of forces. First, before I go into the equilibrium of forces, 我先讲到 Newton's third law. Newton 有三个 law. Newton's first law is the law of inertia. Second law 是等于 F 等于 ma. 然后 Newton's 的第三个 law, third law, is normal reaction, right? Normal reaction. So the general saying is this. This is the general saying. Every action has equal and opposite reaction. Every action has equal and opposite reactions. So this is a very general saying, but if you convert into real meaning, okay, let me write it out for you. This is the real meaning of this sentence. Okay, in an interaction between two objects, opposite direction. Okay, read this sentence. This is the real meaning of the sentence. So he says that in an interaction between two objects. So this sentence makes it very clear that you need to have two objects, two bodies. Okay, the force applied by one on second is equal to the force applied by the second on the first, and it is in exactly opposite directions. Okay, so there is an interaction between two bodies. When one body exerts a force on the second body will also exert the same force on the first body. Now, 你看啊，这个 law 它是讲，当是有 interaction 的时候， 它的 force 是怎样的。可是它没有讲到就是 after interaction 会发生什么事。OK， 这个 law 没有讲到这个，意思说它撞了过后，它 apply 了那个 force 过后 ，whether this object moves or stay at rest, that one is not taught by, is not included. Okay, that one is another law. Okay, that one is governed by another law. This law is only it only says that when one object knocks on the other object, this object will also exert a force on it. Whether the object move or not is not discussed here. Okay, yeah? So the effect is not discussed here. We only discuss the forces here. Let me show you an example. So one ball strikes another one. Okay, let's call this body 1, this body 2. Body 1 strikes body 2, so it will exert a force on body 2. The force is acting on body 2, so it was 把它写成 F2 by 1. Okay, so the force is acting on body 2 by body 1. At the same time, this body will also be exerted a force by body 2. Okay, because according to this law, it says that there is also another force in these directions, and this is acting on 1 by 2. These two forces, they are equal and opposite direction. That's what we call normal reaction and action and reaction. Which one is the action? Which one is the action? Which one is applying the force first? Ball number 1 is applying the force, so this is action. And by the rule of nature, the object reacts by producing a reaction. This is the meaning of this one. Every action has equal and opposite reactions. Another example, okay, so if I hold an object on my hand like this, okay, and hold it like this, the weight of an object, the weight of the object is pushing my hand downwards. So there's a force acting on my hand, F, I put it FH, F acting on hand by the object. At the same time, because of my hand, okay, it produces a reaction on the object, force on object by hand. Action and reaction. Which one is the action? The weight of the object is the action. Which one is reaction? My hand. The force produced by my hand is the reaction. Similarly, if you punch a wall, you are doing action. Okay, you are applying a force on the wall. So the force acts on the wall by the hand, and because of the wall, okay, it applies back a reaction on your fist. Okay, so because of that fist, you feel the pain. This is also action and reaction. So if you look at action and reaction now, reaction force 我们也叫它 normal reaction. Okay, normal reaction. 可能你也是 familiar with this one already, right? Because you learned it in Form 4, normal reaction, and the symbol is R, 或者有时候是 M. So normal reaction 跟 reaction 是通常都是有 surface 的时候我们才 label 的。Anything that is resting on the surface, it has a reaction, because if not because of the reaction, it will fall down. So anything that is resting on the surface, it is acted by a reaction force. Okay, now next one. You see, because of this law, right? This law enables us to move around. Okay, how do we move around? If I want to walk forward, okay, if I want to walk on the ground, I want to walk forward, I must apply my foot on the wall, right? My foot will push the ground backward and not forward. Okay, my foot will push the ground backward, not forward. So when I push it backward, what happens? By the rule of nature, according to the law of Newton, the ground creates a reaction that pushes me forward. Okay, so you see it everywhere, normal reactions, action and reaction. Okay, so this one is just a recap of the Newton's third law of motion. Now, Newton's third law of motion has something to do with the balance and unbalanced forces. Yeah, balance and unbalanced forces. So we talked about. Now we go to the next one. Balance and unbalanced. forces. Okay, for balance forces, okay, let me give you a scenario here. Let me give you a scenario. A ball, we take the same example as just now. A ball is resting on my palm. Okay, this is my hand, this is the ball. The ball is resting. What is the force? There's a force, right? There's a force acting on my hand. It's because of the weight. So F hand by ball, and also because of my hand, there's a reaction upward. Now, here's a question. FB force on ball by hand. A question here. 如果有 reaction force acting on 那个球啊，为什么那个球不会走上去呢？ There's a force acting the reaction. Okay, why doesn't the ball move up? This force has nothing to do with it because this force is acting on my hand. It's not acting on the ball. This downward force is acting on my hand, right? So you see, because there is one more forces. There's one more forces. Why the ball does not move is because there's one more forces. Is the gravitational force is acting on the ball. Now be careful. Forces, you have to see where is it acting. Is it on this object or that object? We have two objects here. Now F gravity, okay, just call it Fg. Fg, Fb by G. The force is acting on the ball by gravity. So we have total three forces here. Three forces. Now, three forces, you see, if you want to study the effect of the object, in this case, if you want to study the effect of the ball, you want to see whether the ball moves or not, right? You look at the forces acting on the ball. Whatever the object that you want to study and the effect, you only see the force acting on that object and you don't see the force that is acting on the other object. So what do I mean is this. If you want to know whether the ball moves or not, you look at only these two forces. Fb, the force on the ball. This one, the force on the ball. This one is also the force on the ball. So we don't look at this one. This one is the force on my hand. Okay, my hand. So whether the ball moves or not, it does not. Okay, the force does not have an effect on the ball. Okay, it has nothing to do with it. Okay, the force on my hand has nothing to do with it. The force on my hand only responsible for the effect, the motion on my hand. Yeah. So only two forces we are looking at, this one and this one. Now, looking at these two forces, they are action and reaction pair also, right? So which one is action? Action is the mass, the gravitational force. This is action. Reaction is this one. Reactions. Okay. So this is balance. Action and reaction, they are balanced. So this cancel out with this one. We use the word cancel out. Okay, cancel out. That's why the net force in this case is 0. Okay, so whenever you have a 0 net force, meaning no motion or no acceleration, to be more accurate. So what does that mean? This means that this system is a balanced system. A balanced system, forces are balanced and the object is at rest. Now, don't get confused. A balanced system can have a moving object in certain cases. Not necessarily it must be at rest. A balanced system simply means the forces coming in this direction, in these directions, in any directions, they are all producing a 0 net effect. That is a balanced system. Okay, so we say that this is a equilibrium. Equilibrium system. Now, 如果我把我的手拿走, okay, if I remove my hand, so if I remove my hand, the force acting on the ball by the hand is gone, right? This one gone. The force acting on my hand is also gone. Only what's left? Only the force acting on the ball by the gravity left. Okay, so what happened here? So the ball is acted only by one force, which is downward force, F on B by gravity. So there is a net force. What is the net force? The net force is mg. This force is the net force. No other forces acting on the body. There's a net force. So there is motion. There is acceleration. So what happens? The body accelerates downwards and it falls. In this case, we call it what? Unbalanced. Unbalanced and not in equilibrium. Okay, yeah? Now, when I press on a spring, this is a wall, and then you have a spring like this. Okay. When I press on the spring like this, I apply a force on the spring. Initially, when I press, the moment I press it, I apply the forces is unbalanced. Okay, so I'm able to compress the spring. I compress the spring up to a certain point. Okay, so the force from the spring gets bigger and bigger and bigger, and at one point it is enough to balance the force I apply. Okay, now at that point, what is the force acting on my hand? Okay, looking at my hand, the force acting on my hand, the first one is the muscle force. The muscle force is pushing my hand towards the spring. Another force that is acting on my hand is the reaction by the spring. It's still acting on my hand. So two forces acting on my hand. First one, F, the muscle force. Second one is the reaction force. Now, be careful. Notice the word I say, acting on my hand, not the spring. Is there any force acting on the spring? Yes. This muscle force is also acting on the spring. But that one we don't care. We don't care about that one because I want to study only the effect of my hand. Only the effect of this body. My hand is the first body. The second body is what? The second body is the spring. The third body is what? The third body is the wall. 1, 2, 1, 2, 3. Okay, yeah. So as I push, the force from the spring increases, and until it balances the force, there's no more motion. Balance force, balance system has achieved. Okay, yeah. Now another thing, this one, a marker. Okay, let's say I get a pen or a marker. Okay, this body is not attached to any body. If you look at my camera, this body is not attached, is not in contact with any body. Okay, so when I move it like this, I hold it, I move it here. Okay, the only force that is applying on this body is from my hand, right? Because this pen is not in contact with any other third body. So if I push it, of course, it is unbalanced forces and it will move. Now, if I keep pushing it until there's a wall here, okay, a wall here, pushing it until it hits the wall, which one? This is the second body, right? This is the third body, a third party body. The first body is my hand, second body is the pen, third body is the wall. Okay, I push it here. So when it comes in contact with the third body, okay, so there is a reaction produced by the third body. So what is the force acting on the pen? The pen only, not my hand, the pen. Okay, the force acting on the pen is first is my muscle force, and another force is the reaction by the wall. Okay, my muscle force pushing it and the reaction by the wall. So the body is balanced. Which body? The pen. The pen is balanced. The forces acting on the pen is balanced. Okay, yeah. So a system can have many bodies. Whatever body that you want to study, the effect of that body, whether it moves or stops or it accelerates, you only look at the forces on that particular body and not the other forces. Okay. Now, suppose that you have a string here. Okay, a string hanging a pendulum. Forces acting on the pendulum. First one, is mg. Second one is the tension. Okay, if you're only looking at this force mg, the pendulum should fall down. Okay, but the tension, the string prevent it because the string will not break. Okay, so T is balanced by mg. In this case, it is equilibrium. Now, what if I take a electric field? Okay, I put an electric field inside. Okay, let's say I draw a diagram again. Okay, this one. Okay, if I put in positive plate here, positive, positive, positive. Let's assume that this pendulum is positively charged. Okay, so it will swing to the side like this. This is positively charged. What is the force now? What is the force acting on the pendulum? The force acting on the pendulum, so we have electric field, the repulsion, we label on the pendulum F E, electric field. Okay, now at the same time, there is a weight. This one is, let me do it longer. The mass of the weight of the ball, mg. Now, looking at these two forces, what is the resultant forces? If you add these two forces up using the vector addition, you will find that, okay, I put the mg here, you will find that the resultant forces is over here, pointing in this directions. I call it Fr. Okay, if you add these two forces up. Now, you see, this resultant force is pointing in these directions. Why the ball will not drop here? Because there is a third force. Okay, there is another force pulling the object, tension. Notice the direction of the tension. You see the direction of the tension. The direction of the tension is sloping, right? It's sloping and it's parallel to the resultant force. It's parallel to the resultant force. So in this case, when you add these two up, you get this resultant force, but it's still balanced on the tension because the spring, it does not allow the ball to move down because it will not break. So this is a equilibrium system. Okay, now imagine the movement. Initially, you have equilibrium. When you put the plate, the moment you put the plate inside here, what happened to the pendulum? The pendulum moves, right? Initial position of the pendulum is here. Initial position is over here. If I draw it here. As soon as you put the plate here, the pendulum will move. Why should it move? Why should it move? It's because when you put the plate, there is unbalanced forces. Okay, there's unbalanced forces, and it moves in these directions to readjust. Okay, to readjust. So this tension is readjusting itself to balance this resultant force Fr. Okay, yeah? So how much does it move? Okay, how much did it move here? Is this angle over here? Whatever the angle here, the tension, the string is moving this much to readjust. So this is an equilibrium system. The first one, this is also a equilibrium system. Second one. Okay. Now, if the string snaps, what happens? If this string snaps, then you lose the tension. So the only resultant force, there is a resultant force acting in these directions, Fr, so the ball drops in these directions. Okay, so given any system, okay, from this lesson, you need to know, given any system, you need to be able to identify all the types of forces acting on the system. How many types of forces we have? Remember, F equals MA, MG, F, TR. I always ask my students to remember this one. 5 types. We have 5 types of forces. Okay, the common one. MA, MG, FTR, MA, MG, FTR. Whenever you are given a system or a case or a diagram, anything, okay, you always recite this one, MA, MG, FTR, and then you label out. Is there MA? No, then you cross out from the list here. Is there MG? Okay, you label. Make sure you don't miss any forces. Okay, so T, whenever you see string, then you label T. And remember, T is always pointing away from the object. This is the object, so it's always pointing away, and we label it on a string. R is when there is a surface, you label R. In this case, there's no surface because the object is hanging. No surface. Okay. F, friction. Okay, straightforward friction, everybody knows. Okay, mg, weight, and ma. Ma is when there's acceleration, only you label. When there's accelerations. Okay, so when a ball is accelerating in this direction at 2 meters per second square, how you label the force? You label F in these directions. This is the resultant force. Yeah. Okay. 来，我们讲另外一个example 啊。This is first example of equilibrium of forces. Now let me give you another one. Okay, another very popular one, the inclined plane. Okay, the inclined plane. Let's assume that this object is not sliding. Okay, it's not sliding. So recap. Okay, let's recap the effect of forces on the body. If you want to study whether this object will move down or remain at rest, we do what? We look at the forces acting on this body only. Okay, so what are the forces acting on this body only? What are the forces acting on this body? We have mg. Okay, label mg is always pointing to the center of the earth. To the center of the earth. So mg. What we have? We have friction. Friction in which directions? Friction in these directions. Okay, imagine it's sliding down. Okay, and it's stopped by the frictional force. So the frictional force is acting in the opposite directions. Okay, reaction. Reaction 是永远是 normal to the surface. This is the surface. So you have to draw perpendicular to the surface. So it's in these directions. Okay, is there any other forces? Let's go through the list. MA, MG, F, T, R. Okay, T, no string. This one already. Acceleration, there's no acceleration to know. Okay, done. This is the force acting on the block. Now, is it in equilibrium or is it not? Is it moving? You can do the addition to see whether it is equilibrium or not. You see, reaction in this direction, friction in this direction. If I add these two up, reaction in this direction, friction in this direction, I will get a resultant force of upward, Fr, and you can see there's the third force, mg, acting downward, and that is the force that balances my resultant force. Okay, so this resultant force upward balanced by mg downward. So the net force in this case is 0. Can we say this is equilibrium? Yes, this is equilibrium. 如果你不要这样子加你的 force， 你也可以这样子做，也可以用我们学了的 triangular addition. We start from one point， 我们选其中一个 force， 我们选 mg， 下来 label mg。Okay, now 我们 join what forces next? Okay, friction. I join it from the head to the tail in this way. This is F, head to tail, and then the reaction also head to tail in this direction. You'll see that they go into the same position. We start here, we end here. So how do I draw the resultant force? The same point, so there's no resultant force. There's no vector of the resultant force. This one is also acceptable. Drawing number 2, case 2, case number 1. And this one, case number 2, always they will ask you in the objective question. in your SPM or your test or your exam, they will ask this one, case number 2. They will give you a system, okay, and then they ask you to pick which diagram shows the equilibrium of forces. Okay, so this is using vector addition. You can use the parallelogram also, parallelogram or the triangle method. So overall, this one, again, I recap, balance. What does it mean by balance system? It means no net force. What does it mean by no net force? It means no motion or no acceleration. So what does that mean? Equilibrium. That's it. The forces on an inclined plane. Now I'll give you another one. Okay, I'll give you another one. Let me see if I can. Okay, two string hanging an object. What are the forces acting on the body? Go through the list. MA, MG, FTR. Okay, MA, there's no acceleration. No. MG, okay, MG down. F, friction. There's no any contact. No. So no friction. Tension, yes, there's tension. So this string is pulling the object up. So I label T. This string is pulling the object up in this directions. So T. Okay. If you were to ask to draw the free body diagram, free body diagram means you only show the object that you're interested in studying, the block, and then you only draw the forces. So this is the tension here, this is the tension here, and this is MG. Okay, free body diagram. Okay, given the degree here is 120. 120. Okay. Determine whether the system is balanced or not. Okay, we do the addition. Tension number 1, tension number 2. We add them up. Okay, how do I draw the forces? We start from here, mg down, and then the first tension in this direction, T, and second tension in this direction, T. Again, they fall to the same position. So this system is also balanced. It's also balanced. Okay, but the problem is in the exam or in the test, in the question, they won't, the typical question, they will ask you to calculate what is the tension. 他会教你算这个 tension 是多少。Okay, how do we calculate that? How do we calculate that? Calculate the tension. Okay, let's do it. To calculate the tension, first step, you need to know that the system is in equilibrium. You need to remind yourself the system is in equilibrium. So what does it mean by, what does that tell you? So remember this one. Maybe you can write this down if you want, or you can just take a screenshot. When the forces acting on object are OK， 来，我们看这个下面这个。It says that when the forces acting on an object are in equilibrium, the resultant force acting on the object is equal to 0. Okay. If the forces are resolved, okay, this one, if the forces are resolved into horizontal and vertical components, then the sum of all horizontal component is equal to 0. Okay. And also the sum of all vertical components of forces is equal to 0. 它意思讲是，如果你有一个 equilibrium system， 你 resolve 完全部 force，OK， 比如说这边我有3个 force 啊，1、2、3，我 resolve 这个 force， 还有我 resolve 这个，我 resolve 买这个，总共的 horizontal forces 啊，加起来它的 sum 是0 ，vertical 也是。如果你的 vertical 全部加起来也是0的话，这样它就 prove 这个是 equilibrium system。我们就是用这一个 law, we use this rule to find the tension. Okay, let me show you how to find it. Okay, if I go to the next slide, okay, this later I will post all the slides in the group chat. Okay, so that you guys can take down. Let's use the same question. This one, 2 string, right? 2 string. Catching. Okay. Mg, and then we have tension number 1, tension number 2. This is how many degree? This is 120 degree, right? So 先单单画 force 过来，我把我的 object 当作是一个点，所以 force mg， 然后120 ，OK， 120我可以 separate 它，我可以讲是这个是 this is the x axis and this is the y axis。OK 啊，120，所以意思说这边是60，这边是60。那现在我开始 resolve 我的 force， 我已经知道这个是 equilibrium 嘛，对不对？所以意思说我 resolve 它的 force， 然后我加起来，它是一定是等于0的，它是 balance 的。OK， 我先 resolve T1， 然后 T1 这边是60度 ，T1 我可以 separate 它去2个 component， 一个 component 是去这边，一个 component 是上去。OK， this is T1x， 这个是 T1y， 意思说 T1 in the y direction and T1 in the x direction。So T1y 是等于多少？如果我要 resolve T1 去的 vertical component 呢 ，if I draw it like this, because it's very hard to see inside, I draw it out like this, so you can see clearly. This is T1x, right? 等于 T1 sin 60，这里是 T1y 是等于 T1 cos 60，这边是60度，可以吗？所以我 resolve 这个去2个，可是我不知道 T1 是多少嘛，我写这边，然后 T2 呢 ？T2 这边也是同样的 ，OK，T2 它的 vector 是这样子，我 resolve 它去这样子，还有这样子，这边是60度，所以 T2 这里是 T2 cos 60，OK， 然后这里是 T2 sin 60， sin 60。One is cos, the other has to be sin, if they are perpendicular. So they are perpendicular. OK， 现在我 resolve 全部 force mg 我要 resolve 吗 ？mg 我不需要 resolve， 因为 mg 它已经是在 y axis， 它也是 OK。I repeat 啊 ，mg 我们不用 resolve， 因为它已经是在 y axis， 它已经是算是 vertical component 了。所以我 resolve 完了，我画我的 force， 它看起来是这样子。OK， 这个是 y axis， 这个是 x axis， 然后我这边有 T1 cos 60，这个是 T1 sin 60，我还有这个 T2 cos 60，然后 T2 sin 60，过后最后我有一个 vertical G 下面 mg。OK， 现在我们 apply 刚刚的那个 rule 啊，它讲 equilibrium equilibrium system， 它的 sum of horizontal 是 zero， 什么意思是 sum of horizontal 是 zero？ 它的意思是讲它的 horizontal 的 forces 全部是 balance， 去左边的是 balance by 去右边的，所以我可以写 T1 sin 60等于 T2 sin 60，因为 the sum of the fx is equals to 0. This one. This one means the sum of fx is equal the sum of the horizontal forces. You add it up, add it all up, you will get a 0. Okay? So T1 sin 60是 balanced by T2 sin 60。所以从这里我割掉，我知道 T1 是等于 T2， 所以它们是一样的，它们的是一样的。OK， 是多少呢？我要算哦。OK， 我现在我用 vertical 帮我算。vertical 我有两个子区上面，这个还有这个，我有一个子区下面，所以我知道这个两个加起来是等于下面这个，所以我就写出来了。T1 cos 60再加 T2 cos 60等于 mg。OK， 那现在我知道 T1 跟 T2 是一样嘛？所以我直接把它们写成 T 罢了咯，我不用再分 T1、T2 啦，T 罢了 ，T60 加 T60等于2T cos 60等于 mg， 然后我就找 T 咯 ，T 等于 mg whatever is the mass and the g I divide by 2 cos 60. Okay, let's take the mass as 2 kg. Okay, so 20 over 2 cos 60. What is the answer? 20 2 cos 60. Oh, the answer is 20. So T 是等于20 Newton. From here, I know 20 Newton is acting on the string, and this one also 20 Newton is acting on the string. So this one allows me to calculate, given any object, what is the tension on the string? Why is it important? Because a string has a maximum tension. Okay, if you exceed the maximum tension, it will snap, right? So you have to make sure it is below the safe level. It is at a safe level, below the critical tension. Okay, so these are calculation of forces in equilibrium system. Okay, so this is the typical question that will be asked in the exam or your test. Yeah, so you can take this down. Take this down. Okay, 2分钟过后就继续。 Okay, now example 1, we look at a few questions. Figure 2.142 shows traffic light weighing 200 Newton being held by two identical cables at an angle of 60. Okay, calculate the tension of each other. Okay, so this one is very similar to just now. Very similar to just now. So you can try doing this one. Weight is 200 down. You have tension 1 here, tension 2 here. Okay, let's resolve. Let's resolve. 我们先 resolve 这个 tension. So 这个 tension resolve 去 horizontal 是 t cos 60. So 它的 vertical 是 t sin 60. 同样，这个是 t cos 60，上面是 t sin 60。OK， 下面20、200牛顿。OK， 所以你 resolve 完了，全部已经是在 horizontal 跟 vertical， 你就可以容易看它 balance 了。所以这个加起来，这个是等于这个，所以 t sin 2t sin 60等于200。t 等于200除2 sin 60。115.47. So that's the answer for this one. Okay, next one. Example number 2. Okay, later I will post everything in the group. Okay, example number 2. A boy weighing 450 sits on the surface inclined at angle 40 with the horizontal slope. So meaning that here is 40. Okay, calculate the normal reaction and the frictional force F acting on him. Okay, we draw the forces. The body, which one? We are calculating the body of the boy, right? The body. So we only study the forces acting on this body. So we are treating it as one point, the weight here, and then we have reaction in these directions, and then we have force. 这个 force 跟这个 reaction 是90度 perpendicular 的。为什么呢？因为你的 frictional force 是 parallel to 那个 surface 的，然后你的 reaction force 是 perpendicular to 那个 surface， 所以 friction 跟 reaction 是 perpendicular 咯。这样子的话 ，OK， 这样子 ，and this is the reaction, this is the body. Here is given 40, right? 40. Okay, can you try doing this? Can you try doing this? F, R. Try to find F and R. I will tell you the solution in 3 minutes. OK， 它的 force system 讲话，它的 angle 啊，你要放 angle 进去啊。So W，我们先画 x y axis 先，x y axis x y OK reaction R and this is F。OK， 如果这里是40度哦，这样还有哪里呢？这边是40度哦。如果我画一条线这边呢，这里也是40度。这里是40度。So here is 40. Here is 40. Here is also 40. Why? Because these two are perpendicular, right? These two are perpendicular. So if this force is twisted like 40-degree clockwise, then this one also 40 degree because they are perpendicular. Okay, so that is 40, this one is also 40. So with the angle, then you can calculate. Okay, resolve. We have three forces, F, R, and W. Resolve all of them. W no need because W is already the vertical component. It's already the vertical component. So F 这个是 F cos 40 horizontal 下来 vertical 就是 terbalik 啦，就是 F sin 40，然后 R cos 40 and this one is R sin 40 and then M. The weight of the boy is 450. You are asked to calculate what the resultant, the reaction and the frictional force. Huh? So taking the sum of Fx equals to 0. The sum of Fx, the sum of the forces equals to 0, meaning that this must be balanced by this one. Okay? So F cos 40 must be balanced by this one. I write F cos 40 equals to R sin 40. Equation 1, vertical F sin 40 plus R cos 40 equals to 450. Equation number 2. Solve the equation. Find F and find R. Simultaneous. You should be able to get the answer 344.72 and 289. 这个你可以这样子弄吗？从1 F 等于 R sin 40除以 cos 40，然后你就写 R sin 除以 cos 就是tangent 嘛 ，R tangent 40，然后塞进去的 ，so you get R tangent 40 times sin 40 R。好的 answer。 Next one. Next question. Example 3. Two boats P and Q are used to pull a raft carrying a few elephants. Okay, boat P uses a force of 4500 in direction of NW 是 northwest, northwest, and boat Q uses force of 5000 in direction of northeast. Okay, calculate the magnitude of the resultant force. Okay, you draw the diagram. Draw the diagram. What is the forces acting on this one? This one. Not the boat, not the boat, not this boat, and not this boat. We are interested in studying the forces acting on this one, the raft. Here, the raft. So we treat this as a point mass. Okay, point mass. And then draw the force diagram. Okay, draw the force diagram. So here you have this force here and this force here. 这里是30度，这里是20度，只有两个 force 哦，这个 F1 跟 F2 只有两个 force。OK， 你就算台湾你算什么 magnitude 跟 magnitude of the resultant force 啊 ，OK magnitude of the resultant force。所以你看啊，他讲 resultant force 意思说这个不是 balance 哦，这个 system 不是 balance 哦。如果这个 system 不是 balance 的话，你会拿到什么？你的 sum of horizontal forces 你不会拿到0，你会拿到有 value， 然后那个 value 会跟你讲它是 acting on left 还是 right。Okay, now let me show you this one. Okay. We have two forces here. F1 is 4500. This one is 5000. Yeah, angle is given. So let's resolve the force first. 我们 resolve 它先。我们 resolve, okay, F1 cos 4500是上面的 F1 cos 4500。sorry, F1 cos 4500不了，4500 cos 30，4500 cos 30，这边就是4500 sin 30，然后5000 cos 20，5000 sin 20。OK， 所以是这样多罢了。那OK， and then you calculate the values. What is the 我们先算 sum of the fx 先 ，sum of the fx forces。OK， 那我们不可以写等于0哦，因为它不是 balance 嘛，所以我只是写 sum of fx， 我不知道是多少。sum of fx 给我们看这个 horizontal forces 这两个4500，你先算那个 value 4500 sin 30，就等于2250，所以这个是2250 Newton。5000呢？5000 sin 20，这个是1710等10。所以2250是去左边，1710是去右边，这样它的 resultant force 在哪里？就是去左边咯，大的那个嘛，2250减10，所以你会拿到539.90 Newton。这个是哪里的？这个是 left 的咯 ，left， 或者你可以直接画这样子。OK， 那个是 for horizontal force， 然后我们做 vertical force Fy， 它加起来就可以了，4500 cos 30，然后加8595 ，OK， 8595.58，这个是 up。OK， 现在我们要怎样做？把这个两个加起来。 OK， 从这个 force system 啊，我已经是 reduced down to this one. The same body, point mass. Okay, so the only forces left acting is this one up. 8595.58 Newton， 然后还有一个是左边，这个是539.90 Newton。OK， 我把全部 forces 变成这个两个，到最后，过后怎样？找 resultant 咯。Addition, this one is addition. You got two forces left, and these two forces is they are perpendicular, right? So we can use the triangle method. So this one becomes 8595. Join from the head 539.90. This is the result. FR. Then you calculate the result. Okay. Square root 539 square 加859 square. Pythagoras theorem. 539.90 square， 然后加859.58 square root， 然后你拿到86 resultant force 是8612.5 Newton. So this is the answer. 8613, very close. Angle, then you calculate the angle here. Angle is over here, this angle here. So we use angle equals to tangent minus 1, 539.90 除 8595.58, about 6.4 here. So 6.4 northwest. That's how we get the resultant force using everything that you learn combined. What we learn here, what we use here, we use the resolution of forces. We also use the net force concept. We also use the addition, the triangular addition. OK， 那可能你觉得，哎呀，这么要这样长，为什么我不要直接把它的 force 加起来呢？你也可以这样子做，也是没有问题。可是你要小心那个 angle 咯。OK， 你也是可以这样子做啦。你看啊，我把 force F1 这个是30度嘛，对不对？30度，然后我直接加 F2， 意思说我 connect 去它的头那边，我 connect 它的头，所以这里是 F1， 然后 F2 是这边 ，F2 这里是20度嘛，这里是20度，这里20度，这里下面是30度，所以它的 angle 这里是什么度？这里中间是30加20 50，这边是130，130度。So 你现在是，如果你用 addition triangle addition 啊，你直接做 triangle addition 啊，你拿到的是这样子的 triangle， 这个是 resultant force FR， 你就算了，这个 side 是几长，你可以算到啊，那个就是它的答案了。你也是可以这样子做，也是没有问题的。意思说我不用 resolve 那个 force， 我直接做 triangle addition。可是问题就是你要用 formula 来算这个长度咯，因为你用不到 Pythagoras theorem 嘛，这个都不是 perpendicular， 这个是130度哦，对不对？你拿到的 triangle 是这样子哦，这边是130度哦。OK， 然后你的这个 FR 哦，它又不一定是直直的哦。OK，it can be slanted a bit. Okay, not necessarily it is straight. So you have to calculate the angle. You have to calculate the angle. 这个 FR 不是直直上去的，它是有一点斜这样子，有一点 angle 对不对 ？Okay. So that's the challenge. That's the challenge if you decide to use the straight away use the triangle addition. If you decide to straight away use, that's the challenge. Or you decide to use straight away the perpendicular method, the parallelogram method also can. You also can add it using the parallelogram method. Okay, no problem, no problem. Okay. The reason I show you this one is because I want you to get familiar with the resolution of forces. Resolution of forces to find the unknown. 如果你用 parallelogram method， 你要量到很清楚，因为它的 angle 比较奇怪啦，又有30又有20这样子。你要用 projector 帮你量。最容易的方法是什么？最容易的方法就是你用 scale 来画。你看啊 ，F1 是4500，F2 是5000。你可以用 scale， 1 cm 是1000 ，OK， 1 cm 等于1000 Newton。然后我就画这个 F1， 我画这个 F1 4500，对不对？我用4.5 cm， 所以 F1 4.5 cm， 然后我要量它的 angle，F2 也是5 cm， 我要量它的 angle， 然后我就画一个 parallelogram， 然后我就找它的 net force。net force magnitude 怎样找？我就量它的长度，因为我都是用真正的 scale 来画嘛。我量它的长度，然后我可以直接量它的 angle。你也是可以这样子做，可是你需要量哦，你需要位置来画哦。在 exam 里面呢，我们很少用这个 method graphical method. This is we call graphical. Okay, you get all the answer by drawings. We can straight away use geometrical, like the one that we use here. Okay, example 4. Later you go back and you try yourself. Okay, later I will send the question to the group also. Okay, question example 5. Last one. I show you one last question, and then you try out the exercises. Okay, example 5. Very similar also. Very similar also. Okay, suppose a body is acted by the force system shown. Determine the magnitude and direction of the resultant force. Okay, so we want to find the magnitude and the direction of the resultant force acting on the body and state whether the body is in equilibrium. Okay, now let's resolve. We have all the angles given, so it's nothing really complicated. We resolve it. So 5 Newton we resolve in this one. So 5 sine 30. Okay. This one, think of this one moving away from the angle, become the vertical. So sine 30, 然后这里就是5 cos 30. Okay, the first force done, resolving. The second force we resolve 10 sine 45 and 10 cos 45. We have another force down here. We resolve it to the horizontal and vertical. Now horizontal vertical 是 based on the Cartesian plane. Okay? 如果你的 Cartesian plane 这样子画啊，这样这个就是 horizontal。你要 resolve 它去那个 x-axis。我可以画不同的 horizontal plane 的。那个 horizontal 那个 Cartesian plane 我可以画不同 direction 的。Okay? 可是我们不要讲那个先，等下弄乱。Okay? we stick to this Cartesian plane. What I mean is you can actually change it like this. You see, you can change like this. I can change my y-axis in this direction, y， 然后这个是 x。如果我这样子换哦，代表什么？代表这个 5n 是我的，直接是我的 vertical component， 因为它是在我的 y-axis 嘛。然后 这个10n，这个10n 是在这个10n 是我的 x component，因为它是在我的 x axis，所以我只是单单换那个 Cartesian plane 哦，我就减少两个 force， 我需要 resolve， 我就可以减少 resolve 两个 force， 因为这个已经是 vertical， 这个已经是 horizontal， 我只是需要 resolve 这个罢了 ，OK， 或者你可以直接用它的 Cartesian plane 也是没有问题的，都是 OK 的，你只是需要 resolve 罢了。OK 嘉俊你的家有电了我有 record 整个 session 因为我有 record 整个 session， 所以如果你要看回，我会 send 那个 link 去那个 group， 还有全部那种 note 我会 send 去那个 group。OK，so 现在我 resolve 这个15n 15n so the horizontal vertical 是5 sin 30，是5 cos 30。OK， 全部我的 force resolve 完了。现在我要加起来，我找 resultant force。OK，sum of vertical forces 5 sin 30加10 sin 45，五 sin 30加10 sin 45，减15 cos 30。OK， 我们先找5 sin 30跟10 sin 45，加10 sin。这个是9.57，我这样子写了。你的 upward force 是9.57，你的 downward force 是5 cos 30， 12.99。OK， 12.99 Newton， 这是 Newton。你的左边的 force 5 cos 30， 4.33。你的右边的 force 14.57。OK， 所以这个加起来，到处你拿的这个，那现在你就减了。OK， 上面跟下面的你就减，下面比较大嘛，所以你的 resultant force 去下面12.99减9.57等于3.42 Newton， 然后14.57减4.33 10.20 in this direction Newton。 OK，resultant 是这样，resultant 就把3.42搬去这边 head to tail， 然后你就画了 this is 3.42， this is the resultant force FR， this is perpendicular so square root 10.24 square 加3.42 square FR。10.80 Newton。 resultant force 10.80 Newton。 angle okay this angle tangent -1 3.42 over 10.24. OK， 18.47，什么 direction？ South Southeast Southeast， sorry， Southeast 是这里的 angle，Southeast 是这里的 angle， 所以我可以用90减掉18.47，找这里的 angle 是71.5。South 71.53 East。或者其实你 show 它这个 diagram 都足够了，你不用写这个71.53，单单 show 它这个 diagram， 你要 show 它你的这个 right angle triangle 啊，然后这个是18.5。Then resultant force 我们用 double arrow 啊。Then you label this FR is 10.8. This is enough to earn you marks. Okay, if you have a question, let me know.